Before computers had fancy graphics with movable cursors and colorful buttons to click on, everything was text. Every operation on the computer was triggered from a text-based interface. These interfaces were known as terminals because they were the endpoints of a network connecting back to a large shared computer. This text-based interface is still present under the hood of all operating systems, and there are programs in every operating system which let you control your computer with text commands. These terminal applications are still the workhorses of much of the workflow for all programmers. If you're not familiar with how to use the terminal on your computer, check out this written tutorial by djangogirls.org. There's a link in the description of this video. It gives a good overview of the basic commands and how to use the terminal in Linux, Mac OS X, and Windows. There's even a video to go along with this chapter of the tutorial by the channel Coding is for Girls. When it comes to getting data in and out of a C++ program, the standard library uses a pattern known as streams. Streams assume all of your data can be broken down into and represented by discrete chunks. In the default case, everything is represented by characters, the char type, which represents 1 byte on most systems. This is a pretty good assumption that's held true for pretty much every modern I/O system. Streams carry an ordered buffer of characters into and out of your program, and there are 2 types of streams that we can use: input streams and output streams. When you're using an output stream or an O stream, you insert your data, and that data floats down the stream in the same order that you inserted it, and you don't have to know any of the details about the device that's downstream that's actually using your data. This stream gives you a standard interface to operate with every output device. Likewise, when you're using an input stream, you don't know any of the details about the input device that's generating this data, but you'll still get a stream of characters that you can parse back into whatever representation is best for your application. And you can even combine both modes with an I/O stream or input-output stream. This is kind of like having 2 streams in one interface. One stream lets you send data out to the device, and the other lets you receive data from the device. You can dig a lot deeper into streams and how they work under the hood, but for now, we know enough to start using them in our code for some common tasks. The stream we care about the most for now is std_cout, the standard character output stream. Std_cout is the standard way to put text on the screen that the user can see. To send data out using this stream, we use the insertion operator. This example line sends the text "Hello World" out for the user to see. And then we have std_endl here. This is another special constant that starts a new line and flushes the stream. Flushing an output stream asks the device at the other end of the stream to go ahead and collect the data from the stream now. This can be useful when working with I/O devices that work on their own schedule, only periodically checking the stream for new data. So let's wrap this example line up in a main function and go try to run it. So here's our same cout example line wrapped up in a main function, which you hopefully recognize from the last video. Let's click run to run it. And we've gotten an error. We can see that the computer is saying that in the function main, good, that's the only function we've got, the error is that cout is not a member of stud. So it's telling us that it doesn't know what the name cout is. Let's take a look at our documentation and see if we can figure this out. And in our documentation for cout, we can see right at the top that cout is defined in the header IO stream. So in order to use cout, we're going to have to include this header. So I've added this line at the top of our example, and now when I click run, perfect, it works and we get our data out. We'll talk about including headers in more detail next week, so don't worry if that was a bit confusing. Let's pull our example function back in and see if we can display our calculated result. So I've pulled back in our trusty example function, %a of total, and I've given it the inputs 5 and 15 for part A and part B. We've stored its result in a variable called %, and then we have our stream output line. We're using cout again for the standard text output. We give it some label text saying this is the calculated result, and then we pass in the actual value, and then we pass in our endline character to flush the stream. The stream iteration operator is nice this way because it lets us chain multiple operator calls together to facilitate formatting our output. So we can go back and forth between text, variable values, more text, more variable values. In fact, let's add a little bit more text to add a % at the end of our line. Now, when we run this code, sure enough, we get our output, calculated result 25%. So what happens if our result isn't a clean whole number? The type of percentage is a double after all. So let's change our example. Instead of saying 5 up here, we'll put 3. And now we run this, and we can see that the result we get is 16.6667%. Good, we've got our decimal places. But who decides how many decimal places we get to see when we print out our fractional numbers? Well, we do, of course. We're writing the code. We can use std setPrecision to tell an output stream how to format a decimal number. You'll see I've included another header to be able to use this function. And when I run it, there we go. 16.666667. We get all of the digits that we want. But there's a trick. If the rest of the digits were 0, they'd get left off. So let's change our example back to 5 and 15 and rerun it. And sure enough, we're back to just printing 25%, even though we've set the precision to 10. If we want a certain number of digits regardless of what their values, we need to use std_fixed. With that added, we click run, and now we get all of those digits back, even if they're zeros. And that's all for using cout for now. There's a lot more you can learn about using cout and the other standard provided I/O streams, but this is a big step for now. We can now start running programs that actually tell us the results they found. We're only covering cout here because most of our robots use other mechanisms to pull in sensor data and output competition-winning behavior. But if you're interested, read up on cin, the standard's default character input stream. This input stream can let you write programs that take input from the command line so you can make more interactive programs. In the next video, we'll talk about how we can make our code do more than just run the same math operations in the same order.